Good evening, everyone. I'm surprised to see so many people made it out despite the smoke, to be quite honest. Yeah. Well, what's that?
No place use a telescope tonight.
Oh, no, I didn't even bother packing it, to be quite honest. Yeah. Yeah. Actually, that is a very good point. If anyone came here to look through the telescope, I have bad news for them. It's not happening. It's not happening. But welcome to the July East Brunswick Astronomy Club meeting. I think we'll get started in about 3 minutes, so hang tight. If you haven't already, we do have a sign-in sheet. It is optional, but feel free to sign in if you would like. And yeah, we'll get started in a couple minutes. So if you haven't been to one of our Astronomy Club meetings, this is the typical agenda that we run through. We do some quick welcome. We go through a presentation. However, this time, if you'll notice, we have presentations on the agenda, which is very exciting. This is one of our probably most interactive meetings that we have here at the club. Last year, it was called Quick Fire Presentations. This year, if you were here at the last meeting, we voted on rebranding it to Astro-Shorts. And so we'll go into that a little bit. We have open discussion, upcoming events, and we already talked about the conditions outside, so disregard those last two items on the agenda. There'll be a shorter meeting. But this is our mission statement. The East Brunswick Astronomy Club is a nonprofit, 501c3. And the idea behind the club is really just to get folks excited about astronomy, space science, and I also forgot to introduce myself. So anyone who doesn't know, my name is Isaac Osores. I'm the president of the club, and we have a couple board members here as well. But you are welcome to bring your telescope on clear nights where there's no smoke. If you're having trouble with it or just want to join in on the fun, you can bring your telescope and we'll help you out. But again, the idea is just to get folks excited about it. And just by seeing the number of people in this room, I think we're doing a good job. And we have 10 online, which I think is a first for us. So for everyone joining us online, welcome. I think we saw someone express that it was their first club meeting as well. So welcome to you. Great. So as I said, this is our second annual meeting of this type, where we really just turn the tables around and invite you to speak a little bit about something that you're passionate about as it relates to astronomy, space, maybe a celestial event that you found really fascinating and want to talk about it. This is the opportunity for you to do that. And we've had a couple people sign up to do so. But one of the reasons why this program excites us, not that our other programs aren't exciting, but this one was really instrumental to have some nice collaboration last year, where we had Paul Fremheim, our VP of Technology, give a presentation around the effects of light pollution on astrophotography. But at the same time, we had Stephanie Holtzman, a science teacher at the East Brunswick High School, present the flip side of that, the effects of light pollution on living things.
Hi, my name is Paul Fremheim. I am one of the board of trustees for the East Brunswick Astronomy Club, and we're going to talk today a little bit about light pollution, how it affects all of us.
My name is Stephanie Holtzman, and I'm a member of the East Brunswick Sustainability Task Force.
When most people look up at the night sky, they might see a handful of stars. But under naturally dark sky, you can see thousands, even the Milky Way stretching from horizon to horizon. Unfortunately, most of that is washed away by light pollution. Light pollution is the brightening of the night sky caused by misdirected or excessive artificial light. Street lights, commercial lighting, billboards, and even home security lights all contribute. That light scatters in the atmosphere and drowns out faint starlight. For astronomers and astrophotographers, darkness is not optional. It's the foundation of everything that we do. In a Bortle 1 dark sky area, the Milky Way glows with color and texture. In cities, that view disappears completely. Even small increases in sky glow reduce contrast and erase faint objects from view. Preserving dark skies means preserving access to the universe. Light pollution isn't just an astronomer's problem. It wastes electricity and costs communities money. It disrupts human circadian rhythms, making quality sleep harder and impacting long-term health. The good news is that this problem is solvable, often with very simple changes. But the impact reaches far beyond astronomy. It affects ecosystems right here at home. And that's where my colleague comes in.
Thanks, Paul. When we talk about greener living, we usually think about recycling or energy conservation. Light pollution rarely makes the list, but it should. Artificial light at night disrupts navigation, mating, migration, hunting, and pollination. Birds migrate using starlight. Artificial lighting from below can pull them off course. Insects are drawn to lights where many die from exhaustion or predation. This reduces pollination and impacts our ability to grow food. Species in East Brunswick like fireflies, moths, frogs, and nocturnal mammals are especially vulnerable. Light pollution is a form of environmental waste. Overlit buildings and unshielded lights burn energy all night long. That increases carbon emissions and raises electric bills for households and municipalities. Communities that reduce light pollution save money while improving environmental health. Simple changes make the biggest difference. Use fully shielded outdoor light fixtures that direct light downward. Choose warmer colored bulbs instead of harsh blue-white LEDs. Use motion sensors instead of constant on lighting. Turn off decorative or commercial lighting after hours. These steps improve safety, reduce waste, and protect wildlife. Protecting the night sky supports ecosystems, saves energy, and strengthens communities. Everyone can help: homeowners, businesses, schools, and local governments. A darker night sky is a healthier environment.
A stronger community.
And a pathway to greener living for everyone.
With that said, we do have Melissa Hozick, our adult programming librarian, who actually helps us a ton at the club. You'll always see her in her corner on the computer, making sure that the live stream is working well, that the chat is being addressed, but she has a couple things that she'd like to go over for us. So she's gonna kick it off, and then we'll go through some of the presenters that we have today. Sounds good? Perfect.
Good evening, everyone. As Isaac said, my name is Melissa Hozick. I'm the adult programming librarian here at the East Brunswick Public Library. I am doing a quick presentation. For those of you who have library cards, how many people in here have a library card? Raise your hand. Good. If you don't have one, on your way out, you can get one if you're an East Brunswick resident. Otherwise, go to your home library and sign up, and you'll be able to access almost all these free, fun things. So we're going to talk about all the free astronomy media you can get with your library card. So we have lots of different virtual databases here that do cool things. We have ones for language, we have ones for newspapers. The two I'm going to be speaking about this evening are Libby, which if you are an East Brunswick library card holder or a Stella library card holder, so it's like basically everywhere but Woodbridge, that you will probably have a card that's considered a Stella library card. You can come ask me afterwards. You can do magazines and ebooks and e-audiobooks on Libby. And then we have Canopy, which is only for East Brunswick library card holders unless your library subscribes. And we have access to lots of documentaries and movies. And both of these resources have some really cool astronomy stuff that you can access for free. So the first one is Libby. It's actually really easy to use. I'm showing this here on the screen of how it works if you're on a browser. You choose Stella Libraries, you type in your library card number. That's my library card number, don't use it. My PIN, that's my PIN, you can't see it. And you click sign in, and you'll be able to just go and you'll see this, it looks like this. You go to the search menu. You can type in anything you want here, but obviously for this presentation, what word do we want to use? Astronomy. So you can see with your library card, you get all of these magazines at the top here for free. Most of them, we have multiple of the issues. If it's an older one, we may not. We also have all these e-books and e-audiobooks, so you can get all this different media for free with your library card. The other interesting thing is, so if you click on one of the magazines, if you want to choose a specific issue where you're like, you know there's an article you really wanted to see, you can just go and click on that issue and you'll be able to download it. So it's pretty easy to use. I use it mostly for e-audiobooks personally. That's my favorite media. Or if I'm stuck at a doctor's appointment, I love a good magazine. And it's not a magazine that's 5 years old. So Canopy is the other service, and it is all video media. So it's documentaries, movies. We have all of the great courses. There's actually a whole bunch of things through the great courses on astronomy. There's a lot of satellite radio astronomy stuff, which I know some of our people here who are officers are huge fans of. But this one, as I said, East Brunswick library card holders only. You can ask your other library, though, to do it if you're South River otherwise here. And you set this count up, unlike with using your library card, you set it up with an email address and then put your card in, and then you're set to go. And this has some really amazing things on thousands of different topics of interest. So yeah, any other of our services you can access here through this QR code or go to www.ebpl.org/virtual-library. Everything that we have access to that is free for you to use, and we would love for you to use it and support public libraries, can be found here. So I hope that you will add these things to your reading and media list, as well as YouTube and TikTok and Instagram and all the other cool things that we have for sharing. So thank you.
Thank you very much, Melissa. All right. So we have our first presenter, Deb Carmody. And I'll just read the bio that was sent over. Deb Carmody is new to the world of astronomy, having recently developed an interest after traveling to upstate New York to see the April 2024 solar eclipse, and after seeing aurora from her backyard in Freehold. Deb works at the Spotswood Public Library and has been thrilled to bring the East Brunswick Astronomy Club and their telescopes, thank you so much, to library patrons there. So let's give Deb a hand.
Last month, I had the opportunity with my husband to travel out west. We went to the Grand Teton State Park, which is in Wyoming. What makes that a really good place to stargaze is there's minimal light pollution. There's Wyoming, I think, is the least populated state in the country. New Jersey is one of the most densely populated. Wyoming is the least. So there's minimal light pollution there. And if you look at the bottom, I don't know how many people are familiar with the Bortle scale. It's a rating system, determines how bright a particular location is and how dark the sky is. So where we were in Wyoming, the Bortle scale is a 2. And so 1 is the darkest sky. So we were looking at really, really dark skies. Here in New Jersey, we're somewhere between a 6 and a 7. So definitely better viewing conditions. We're also out in Grand Teton at a higher elevation. That puts us a little bit above the atmospheric haze, wildfire smoke, certainly moisture and anything else that might block out the clarity of the sky. And then also completely open skies. That area, Montana, I think, is known for big sky country. Wyoming is just a couple of hours south, also completely unobstructed views. I know the frustration here for us in New Jersey, particularly if I go out into my own backyard, is there's trees everywhere. So the amount of viewing space that you have is usually just the small little circles where the tree canopy doesn't meet. So there we go. Okay, so this is the daytime view of where we actually set up. The date that we went was June 17th, so just a few days before the summer solstice. So sunset was actually quite late, 9:07 p.m., but it was 3 days after a new moon. We had planned the trip that way because we knew we were stargazing and we wanted the sky to be as dark as possible within our vacation time. And because we were flying out there and because I'm new to all this, we didn't really have any equipment. We didn't want to bring binoculars with us. So we went on a small group tour with a company called Wyoming Stargazing. The group tour had 10 other people, so there was plenty of time to look at through the telescope, and they provided 2 astronomers, one of which mainly focused on looking through the telescope and focusing on deep sky objects. And the other gentleman did things with a laser pointer, and he did mostly what you could see using your naked eye. The telescope they used was a 22-inch Dobsonian. I'm sure a lot more people in this room would be able to tell you what that actually means, but I think it's a good one. So other perks for us for going with this company was they knew the ideal location to go to. As I said, we didn't need to bring any equipment. They also brought chairs and blankets. As you can see, there's nothing out there. There's no park benches. So having camp chairs was just, more comfortable. And an additional perk is they picked us up right at the hotel. So we didn't have to worry about driving where there weren't any street lights in a location that typically has elk and bison and sometimes bears. So as I mentioned, the sunset was 9:07 p.m. This is over an hour later, and you could see how much residual sunlight was still left. We did have an excellent view of the moon, Venus, and Jupiter. You can sort of see in the center of the screen there. And one of the cool things that I like to spot is Earthshine. And that's when the night side part of the moon gets partially illuminated by sunlight that reflects back off of the Earth. And so normally what you just see is the crescent moon, but if you get a little bit of Earthshine, you can see that whole gray part of the moon filled out. And that only happens during the 2 crescent phases of the moon. Okay, so this is about 25 minutes later. You can see it's getting darker. The one thing that sort of startled me the first time being in a dark sky environment was my go-to sources like asterisms, constellations that I can see very easily here. For me, the first asterism I knew about was the Big Dipper, so that's always my go-to one. I actually had a hard time finding it, not because it wasn't there, but because there were so many other stars in the middle of it, around it, and it was very difficult to sort of focus the eye and figure out exactly what you were looking at. So that was why another benefit for having some professionals with us. They knew exactly where to look. So this is an hour later. So now you can see, really, this is sort of the sweet spot of the night sky. There is a lot going on in this picture, I've learned. But you can see a little bit of the sort of galactic dust, the center of the Milky Way. But I was actually going to put it to you guys to see if anybody knew. If I told you we're looking at the southern sky, and if you see that bright red dot in the middle, does anybody know what we're looking at? Want to take a guess? Yeah, yeah. So that's called the Heart of the Scorpion. This was a constellation that was a favorite of one of the guys that was there, so we talked about it a lot. There's also hints, if you're familiar at all with the southern summer sky, excuse me, there's a hint of another asterism there that's very close to Scorpius. Any ideas? Sagittarius. So these are the exact same images. The one on the right, I just highlighted the teapot a little bit because that's the one I go to. Sagittarius, to me, like many of the other constellations, don't actually look like what they're supposed to represent, but the teapot actually looks like a teapot. And they say that the steam of that is sort of one of the dust bands, the gas bands of the Milky Way. So I was taking all my pictures with an iPhone. And as I mentioned, one of the fellows was really into Scorpius, but he was also into astrophotography, which I know some of you guys are too. So he had some amazing pictures on his iPhone. Mine were okay. I thought it did a pretty good job for an iPhone. But he was giving me some photography tips. Mainly he was saying most smartphone cameras have a night mode. For me, the iPhone happens automatically, but some of the other phones, I know you have to go in and select it as an option. And that helps with, exposure and all that kind of stuff. Using a tripod to minimize shake. Some of my pictures you could see were a little bit blurry in spots. That was just because people move a little bit. But I did find that if I held the camera close up to me and sort of braced my arms a little bit, it did help reduce the shake. And then just adjusting exposure time to as long as possible. I think the maximum that I got was 10 seconds on mine, but the gentleman had said that if I had a tripod, it registers that it's still and will increase your exposure time. But again, we were in the middle of nowhere, so I couldn't even set it up on a table. And then finally, I just wanted to say a couple of things. I thought this was a really great family-friendly trip to take. Usually when you think of national parks, you think of, putting on a backpack and having a canteen and hiking to go look at waterfalls and animals and stuff like that. And that's all great part of the trip as well. But something like this is an all ages, all abilities thing to do. You could have little ones, you could have seniors, you could have people that had limited mobility because all you had to really do was sort of step up to an eyepiece and look through it. My other tip would be dressing in layers. It was in the 80s during the day. I went in a pair of leggings and a long sleeve t-shirt, but by the end of the night, I had second pair of pants on. I had a sweatshirt, a jacket, hat, and gloves. I was cold. And I was glad when we went back that they put the heat on in the car. So it had dropped. And I think just when you're out there for an extended period of time, your body just gets colder anyway. And then lastly, I really think it was a great experience. I sort of want to do it again whenever I get a chance to go out in some place. It's radically different from the New Jersey sky, which is great and it's fun to look at, but this was just absolutely awe-inspiring. So if anybody gets a chance to head out west or any of the other places, I would recommend a trip. I just mentioned to the folks online that there was no bison flipping like we see on the news this week. We did see herds of bison off to the side.
Oh, nice.
We did have some within maybe 50 yards of us. So that was pretty cool. Elk, we had go in front of the car. We did have bison going behind our car. A family, a bull with a baby that was moving behind us. That was pretty cool. I did briefly spot a bear, but he was running away from the park rangers that were there, so I didn't get a picture. But definitely, if you're into wildlife, it was a lot of fun.
Very nice. Thank you.
So, sure.
Thank you very much.
Any other questions?
Besides constellations, did your tour guide also showed you any like planets or any like certain nebulas or galaxies?
Yes, we focused on Lyra, Cygnus, and then Scorpius and Sagittarius. And so within that, Vega, what was the other one? I always want to say Alberto. Abirio, what's the one? Somebody help me. Abirio, something like that. I think it was in Cygnus. I'd have to look it up. I'll Google it. And then the Ring Nebula, the Veil Nebula, Cigar Galaxy, Bode's Galaxy.
Wow. Quite the tour.
Yeah, I mean, we were there. I don't think I mentioned it. We were there probably. We got picked up at 9:30. I think we ended up leaving 12:15, something like that. So it was a good solid 2 hours of viewing. And like I said, one gentleman focused entirely on the telescope. The other one used his laser pointer and pointed at sort of near object things that we could see. It was really cool. I should mention it was kind of pricey for us to do, but I sort of am the belief that I'd rather spend money on experiences than on stuff. So, and we had such a great time, and it was sort of awe-inspiring, almost life-changing when you, like, now I look at the sky and I'm like, oh, here, I'm in New Jersey again. As much as I love New Jersey, it doesn't compare to what we saw.
Is there a website for tours like this or?
So the group that I went to was Wyoming Stargazing, and I found them just by a Google search where we were going to be. We also had gone to Yellowstone earlier in the week. We started in Bozeman, Montana, and Montana has some stargazing stuff, but we were only there for an evening. Then we went through Yellowstone. The Wyoming Stargazing operates out of Jackson Hole. And so that's where our hotel was for one night. And that's why we took the tour. So.
That's funny. I was going to ask if going out there and seeing how dark the sky out there was, if it ruined it for you here, but it sounds like it did a little bit. Thank you. That was awesome. Thank you for sharing that. So we do have Isabella Naylor up next to give a presentation, A Brief History of Astrophysics. Bella is 15 and is the president and refounder of the Spotswood High School's Astronomy Club. Kudos to you. She aspires to one day pursue a career in STEM field. Let's welcome her.
So really quick, at my club, I give lectures. So I wanted to redo a metaphor that I did with them with some of you. So for the theory of general relativity, for those who want one, raise your hand if you want a piece of graph paper, because we're going to use it to make our own mini universe. To the people online, you'll be able to read about it as well, because I explained it in a slide. Okay. So for this presentation, it's a bit of a mix of my old presentations, but I want to do a focus on black holes because, in my opinion, black holes are the key to understanding the universe. They inspire so many people to get into this field, and our knowledge of black holes has been around we've had solid knowledge of them for about 40 to 50 years. The first photographs we got of them were in 2019. But theoretically, we have had the math for the better part of a century. So I think knowing the history behind it will help us even further understand it. So starting off with a simple definition of black holes, that's a photo taken by the Event Horizon Telescope in 2019. I believe that is the black hole M87, but it could also be Sagittarius A. So simply putting it, a black hole is a region of extreme density where space-time curvature prevents the escape of light. And because they suck up light, that's a really big deal because light is the fastest thing in the universe and nothing can exceed the speed of light. So it baffled scientists for a really long time. So next, this is probably one of the earliest theories to precurse our modern theories of black holes, starting with John Mitchell. So Mitchell was a clergyman and a natural philosopher. So in 1783, he came up with a theory. He was wrong, but he was on the right track. So he assumed that the bigger a star was, the more gravity it had. Using Newton's gravity, it would have an amount of gravity proportionate to its size. So the bigger the star was, the slower the light would travel away from it. So then using the rate at which the light traveled away, then you could calculate the mass of the star. We now know that that's not correct. Speed of light is a constant. You know that from, I believe, special relativity. But he then afterwards questioned if it was possible for a star to be so big, like say 300 times the mass of our sun, that light couldn't escape it, resulting in an invisible star. So these ideas became known as dark stars and escape velocity. We now know that black holes aren't quite invisible stars, but were former stars. So next is escape velocity. I think this is a simple definition. I thought it was really interesting. So escape velocity is the minimum speed you need to travel at in order to escape something's gravitational pull. So for the Earth, 11.2 kilometers per second. I'm not the best at math, but I think that's 8 miles per second. Something like that. 7 miles. Thank you. So then let's respect the stuff for the Mars and Moon and black holes. You know, you can't escape them. So next, bit of stellar evolution for you. Those who are at the Lyrae Stars meeting know about the HR diagram. But this is another way to put it. So start off with a gas and dust cloud. So post Big Bang, we have all these elements, specifically hydrogen, and they start to get closer, gravity and stuff, and eventually you get a protostar and a main sequence star. So main sequence stars are your average stars. Our sun is a main sequence star. They're middle-aged, I think maybe like average light compared to some. And they go through a process known as nuclear fusion, where they turn hydrogen into helium. That's what stars burn. But eventually they kind of run out of hydrogen, so they start to burn harder elements, more heavier elements. And the really large ones, they form red supergiants. Then they run out of heavier elements. And then they go into supernova, they explode, and they collapse in on themselves. And the really, really big ones turn into black holes. So when they collapse, they're kind of, in a sense, infinitely collapsing, so they're infinitely dense. Is The last was stellar black holes. But theoretically, kind of anything can be a black hole. This is a little more on how black holes get to be what they are. So we have the Tolman-Oppenheimer-Volkoff limit. So if the star is in a range between 2.2 m or 3 m or exceeds that range, then the star will become a black hole. So M stands for solar mass. One solar mass is about one mass of our sun. I think our sun's the base model. So most times, I believe, it'll become a black hole if it's in that range. If it exceeds 3 m, it is definitely becoming a black hole. It'll collapse under its own weight. Then we have Carl Schwarzschild. So this is the theoretical side of things, kind of. So Carl Schwarzschild came up with the idea of Schwarzschild's radius. So this theory states, if you were to pack the mass of an object to a very dense sphere, squash it all directions equally, then if said sphere is smaller than a certain radius, say x, then it will become a black hole. So the Earth's Schwarzschild radius is about 9 millimeters. I believe that's the size of like a pea, and the human's smaller than a proton. So you could crush anything. It's very hard, but you can try crushing a human into a black hole. Let me know if it works for you. So next, one of the most important people in physics, Albert Einstein. So this is where we get into our metaphor with the graph paper. So I want all of you to take your pencils, and then I will show you also up here. Hold on, people online. So using your pencil, I don't know how long it's been since we've been in a geometry class. I forgot most of it anyways, but the lines going this way, let's label that your y-axis. Just put a y at the top. And then I want you to label that space on the side. And then the lines going horizontally, put an X at the bottom corner and label that time. So space and time are unified according to Einstein's theory of general relativity. Now I want you to hold your paper by the two ends like this. Put your pencil in the middle and hold it and let the pencil curve the paper. That's what general relativity is. General relativity, big things warp space-time. So that's okay. Space-time is very interesting, and almost all of physics is based on it. So I wanted you guys to see how if things in the universe warp space-time, that's what black holes also do. We define gravity in modern physics as the curvature in space-time. So the curve you're seeing, that's gravity. That's what makes gravity. So imagine you have a planet like our Earth. It's bending our space-time paper significantly. So then that's why the moon orbits around us. It goes in a circle around it. So if you want to understand black holes, you have to know the basics like general relativity. So next is a photo which helps you visualize it even a bit more. So as you can see, the sun, very big, it's warping space-time. White dwarfs are even more dense, and neutron stars. So neutron stars is basically the black hole's cousin. It didn't have enough mass to become a black hole, but it got really dense. So it warps space-time to a degree that it is distorting it. With black holes, that's even more extreme. So over here you have the event horizon. The event horizon, for those of you who don't know, is the point of no return. Once something passes the event horizon, there's no going back. And then you reach singularity point, which is, in a kind of sense, the core of the black hole, and it's the end of time. So that's how that works. So you imagine you are a photon, which is a particle of light. You're going around space, and then you're immediately getting sucked into that. So that's what's going to happen. And many theories, we're going to get into what could possibly happen to the stuff after it gets sucked into the black hole. So next, this is a theoretical stuff. I wanted to show people how black holes can even be the answer to maybe a multiversal theory. So wormholes, also known as Einstein-Rosen bridges, are just general relativity taken one step further. So wormholes are just distorted space-time geometry. So imagine that the singularity point of a black hole didn't exist, but there's still an event horizon, the surface of the black hole, point of no return. So an object will fall into the black hole, go through the wormhole, and end up on the other side of the event horizon. This is theoretically known as a white hole. So black holes suck things in, white holes spew things out. So in some theories, ER equals EPR, then that could maybe be the white hole. It is in a parallel universe because of how much we distorted spacetime. In some theories, one of the theories for the origin of our universe, it's theorized that our universe started as a white hole. So the Big Bang was really just a white hole spewing everything out. That's just one theory, though. So next, we did general relativity. Now we're gonna get to the very small quantum. Schrodinger's cat. I love Schrodinger's cat. So many of you may know about the Copenhagen group. So Erwin Schrödinger didn't really like what people were doing in Copenhagen, their whole science group. They came up with a theory known as quantum superposition, which is the idea that atoms can exist in many states at once until observed. And Werner Heisenberg took it even further and said, actually, we have something called the uncertainty principle, which means that an atom, we can never really know its speed or position. The more you measure its speed, the less you'll know about the position. The more you measure the position, the less you'll know about the speed. So things started to get really complicated. Erwin Schrödinger was like, that's a load of bull, man. So he responded with this theory. This theory was actually to mock them, but it became one of the most essential theories today. So you have a cat in a box, and within said box is radioactive material. So you have a radioactive atom that may or may not decay. Then you have this like detector, and it'll detect that. And if it does detect that the atom has decayed, then the vial of poison will break open. The cat will be alive or dead until observed. So until you open the box, the cat is both alive and dead. It doesn't make a lot of sense, but physics allows this. So Erwin Schrödinger released the theory, then other brilliant scientists built on it. And they came up with something known as the many worlds interpretation. So the many worlds interpretation states, okay, so I have the cat, I open the box, the cat's alive or dead. Say in this universe, the cat is alive. But what if the cat was also still dead at the same time, even though we already saw it? What if the cat's alive in this universe, but at the same time it's dead in another? Then we maybe have multiple universes. So we now have two theories that say we could have multiple universes. One is quantum, and one is built on general relativity. However, in physics, physicists are trying to work towards something called a quantum theory of gravity. Basically, it'll unite physics. So when scientists do the math with quantum, the very small, and general relativity, the very big, they end up with numbers that don't make sense. But if we can work and keep working on stuff, we can find a theory, because some could say, well, what if one of them's not right? But the math has been done over and over and over again, and we know that general relativity is like 99.9% right. So is quantum mechanics. So that shows that we still need to get going in science, and there's still more to be done in physics. So black holes can very much be our key to understanding the universe. So I'm going to end on that note, and thank you all for being such a wonderful audience.
That was great. Thank you so much. Does anyone have any questions for Isabel?
I am a rising sophomore. I'm 15. So I research this in my own time. I'm president of the Astrophysics Club. So I do presentations in my free time, and then I present them to the kids at school as scientific outreach to get more kids involved in science.
Do you believe, with all the theories of wormholes and Schrodinger's cat, that we could one day find a way to cross between universes or find a way to access other universes if astrophysics continue to be studied in? Or do you believe that all of these are nothing more than theories at best?
I think right now our technology currently limits us greatly. Um, there have been attempts about a quantum theory of gravity with Leonard Susskind, Juan Maldacena with the anti-de Sitter space and holographic principle. However, they are just theories. I think with enough time, we will be able to do something. And even if we do have the math to understand these theories, I think other things can also limit us, such as like where are we going to get this energy from? Because, like I said, speed of light is constant. Nothing can travel faster than the speed of light. So perhaps there's certain laws holding us back. And wormholes are purely theoretical. We haven't actually seen a wormhole, so maybe we'll get to another universe. But as of right now, and in this century, I don't see it likely.
Okay. Do you believe in any of the theories personally, or?
I believe that general relativity is probably correct. Quantum mechanics wasn't necessarily taken seriously for a long time because of how crazy it is. Schrodinger's cat's a little out there. But I believe in most physics. I read papers, and there's definitely stuff I disagree with. So what I encourage the kids at school to do is research things and see what you think makes sense. Because even in the scientific community, I'm sure there's a physicist reading someone else's paper right now, laughing about how absurd it is. So,
Well, we can only hope.
as for that, um, I'm not too sure. Modern physics, I do like Professor Brian Cox. He's doing some research, but I started off with physics reading Stephen Hawking, Kip Thorne, Roger Penrose. For me, I don't have the math abilities to be able to read a modern day like physics papers that scientists are being put out. But for those interested, I highly recommend authors like Stephen Hawking because they write something called pop science books, which are theoretical physics made for the general audience. So that's where I get a lot of it from.
Yeah. Nice presentation, nice, very good. Thank you for that. And the unifying both, bringing them together, not unifying the quantum mechanics and then general theory of relativity has been happening for the last maybe 70, 80 years. There's no success so far. What we call GUTS. GUTS means grand unified theories. Grand unified theory, where you bring together, you don't agree. One is in a bigger scale, gravity and all, and then the other one is weak interaction, strong interaction. They happen in very small dimension. So I don't know exactly right now at what stage these things are, but there is no convergence of these two so far. Okay. And as far as that part thing is concerned, Heisenberg's uncertainty principle, we call it particle in a box, right? You might have heard that. This is for layman, you explain this particle in a box. It can exist in multiple states. At that time, he said 2 states. It exists, it doesn't exist. Now, it can exist in multiple states. Recently, Google claimed that they, during some quantum computing, they said they entered the multiverse. But I have not heard much about it afterward. They just made a claim, but I don't know much has happened after that. Whether it is peer reviewed or not, we don't know. But a lot is happening though. But the first one, right, you mentioned Mitchell, right? At that time, light was considered to be made of particles, like Newton's theory of particles, right? Particles of light. He thought particles can be, you can estimate the size of the star based on this size of the, how fast it can move. Because he thought it was particles can be attracted by gravity, by larger bodies. So, but that was the reason at that time. Now, Chandrasekhar is the guy who actually called it in 1920s or 30s, I think it was. He was traveling in a ship to go to Cambridge. At that time, he came up with the idea of black hole. He didn't call it black hole, but it collapses at some point. And short-sighted radius was already there by that time. And he estimated that it is going to be, he gave some calculations for that. Now, Chandra telescope, you know, right? It's named after him. Yeah. He was the guy who actually called it, this is possible, based on Einstein's theory, general theory of relativity. Thank you. Just a comment, that's all, not a question.
All very important scientists, loads of research. I think it all just points to how far we've come in physics, but also how far we still need to go.
Anyone else with questions for Isabella? I have a question. The club that you started, in your bio, you mentioned it was you were the refounder.
Yeah. So my club advisor, he said that there was, well, I did some digging in the old yearbooks because I was very passionate about going to college. And I was like, I need to do extra stuff to get into school. So I found out we had an astronomy club from, I think, 1998 to 2002. So one day I went to the teacher, the physics teacher, and I was like, I'm trying to start a club. I was thinking astronomy. He was like, let's do it. So we didn't have a club for 24 years, and I bought it back.
No, that's awesome. I'm glad you took that endeavor on. Awesome. That was pretty cool. So to be quite candid with you all, we did only get those two folks to sign up to give, as you saw, a quick presentation. It's not like your typical presentation where we have someone usually on the screen, sometimes in person, give an hour-long presentation, but again, giving folks the opportunity to come up and talk about something that they're very interested in and passionate about. I'm feeling brave and want to open it up to anyone who here, maybe after seeing the two presentations, wants to have a quick chat about something. But if not, no worries. This is a series that will keep going, and you know, we'll get more signups next year. But open call for anyone here who would like to do an impromptu talk about something astronomy or space related.
Hi, everyone. I had given a presentation previously, and it was about the sort of a brief biographies of some notable amateur astronomers in the past. And I can't remember if I include, well, I definitely discussed one such personage, Percival Lowell. I don't know if any of you recall that, but what I don't recall is if I did spoke much about the legacy he left, a very important physical material legacy, and that is the Lowell Observatory in Flagstaff, Arizona. Okay, so again, this is part of the presentation I gave about the famous amateur astronomers, and I called this particular personality, Percival Lowell, the king of amateur astronomers, because he was not a trained professional astronomer. He was not a professor at a university or anything like that. He had a BA from Harvard University in math. He was a mathematician, or he received his bachelor's degree in math, but he became a career diplomat. He worked for the United States State Department, and did most of his work for the State Department in the Far East. He was Foreign Secretary, counselor in Korea, and he was living in Japan. He wrote several books on Korean and Japanese culture and society. He was a fellow of the American Academy of Arts and Sciences, but really didn't do anything with science or astronomy until he retired. He came home, he read a book on Mars, La Planète Mars, by a Frenchman, Camille Flammarion, and then he became familiar with the drawings of an Italian astronomer, Giovanni Schiaparelli, which depicted these canal-like features on the surface of the planet. And this kind of like fired his Percival Lowell's imagination to the point where he developed an obsession with Mars and decided then to become involved full-time in astronomy. Lacking a formal education in astronomy, he became self-taught. He dove into books about astronomy. And because he was wealthy, came from a wealthy family, he did what all of us other amateur astronomers dreamed that we could do. He actually built his own personal observatory on the mountaintop of Flagstaff, a mountaintop overlooking Flagstaff. And so that's a picture of it there, looking like an inverted ice cream cup instead of the usual round dome. And within it, he had commissioned the building of a 24-inch refracting telescope, which is called the Clark telescope, because the person who built it for him, his name was Clark. He built this in 1894. So I made this trip to Flagstaff, Arizona. This was quite some time ago now. So back in 2009, I believe it was, that I went there. And so this is, you can see some of the construction of the observatory, where we're mostly familiar these days with all metal construction, whereas what's the most abundant material in Flagstaff, Arizona at this time anyway, is lumber. So the observatory is built entirely of wood, of lumber, and it's incredible. I mean, if you look at it and you see how much carpentry went into this, and it is, in fact, today impossible. If there were a fire, they're very careful. For all visitors who come there, of course, there's no smoking, nothing that would possibly start a fire, because if this thing were to catch fire and burn down, it would, at the cost of lumber and labor today, it would be impossible to rebuild. What you're seeing here on the right, those two structures there are views of the mausoleum in which Percival Lowell's remains are interred today. And I always thought of it as, looking very much like a spacecraft. And I could imagine, if you look at it and think of it long enough, you could imagine it lifting up off the Earth, floating out into space, and eventually landing on Mars, which is what Percival Lowell would have loved, absolutely, would wish for. Here are some examples of the drawings. He would sit at the eyepiece of that telescope of his for hours on end, and he would make sketches, because again, there was no astrophotography at that time. So what all astronomers did was they would make sketches of what they saw. And so his hours of viewing in the telescope was mainly at Mars, and these were the results of his observations. And again, he was particularly interested in these features on what he saw on the Martian surface of these canal-like structures. And so they featured largely in his sketches. We know today, of course, that they don't exist. There are no canals on Mars, and there aren't even these features that could be, that are these straight line uh, um, um, drawings. It's just interesting how if one wishes to see things and then ends up drawing them, you will see these. Your imagination will come to the point where you will see them and you will reproduce them on a piece of paper, but they don't really, unfortunately, don't really exist. As a result, Percival Lowell at first created a sensation by presenting these as in papers, scientific papers, which caused the scientific community to be aroused to the fact, well, gee, maybe there is this intelligent form of life elsewhere in the universe, and maybe, as Percival Lowell is making the claim, that it exists here on Mars. But unfortunately, as other scientists, astronomers, became interested and did try to follow up on his studies, it became evident that it really was, there was not much real substantiation for the evidence that Percival Lowell was coming up with. And so he began to become discredited and unfortunately was eventually ostracized from the scientific community. Nevertheless, these popular images of life on Mars persisted well into the middle and later part of the 20th century. And, I myself, oh, by the way, I hope you all appreciate my Marvin the Martian t-shirt. I'm a huge fan of Marvin the Martian. And it's a shame, that perhaps he may not really exist, but boy, there are those of us who really wish he were there. And some of these other fantastic imaginings that were popularized by Hollywood or materialized by Hollywood. That it even got to the point where some people speculated that what Lowell was seeing, not only was it his imagination, but what he was seeing was actually the reflection of the retina of his eye. So that you see way over on the right, that the retina of the eye has these capillaries in the retina, and they can actually be reflected into an eyepiece of a telescope. And that's what he probably, nevertheless, he did make some very important contributions to astronomy, which persisted. And one of those was he made these calculations. He was observing Neptune, the orbit of Neptune, and he came up with some mathematical calculations because of his training in mathematics. And he said, there's a strange perturbance in the orbit of Neptune, which is, can only be just explained if there were, in fact, some other body out there, some other body that had a gravitational field which was causing this anomalous orbit of Neptune. So